This video talks about the next type of reactions, which is to take an alkene and turn it into a diol. So both carbons will have an OH group on it. So this is called dihydroxylation. Di because there's two, and hydroxyl because hydroxyl is an OH group. There's two different ways to do this, or there's actually lots of ways, but there's two primary ways to do this, and we're going to talk about both of them. One of them makes the two alcohols cis to each other, and the other one makes them trans to each other, and they use completely different mechanisms. So the first thing we're going to talk about is trans dihydroxylation. To do this, the first step is to take an alkene and add a peroxy acid. So this R can be anything here. And then notice it has an O3. So this is like a carboxylic acid, but it has two oxygens stuck together in the hydroxyl group, and it's called a peroxy acid. And it makes this group here, it's called an epoxide. We're not going to talk about the mechanism here. If you wanted the epoxide, you could stop at this point. MCPBA, which is metachloroperoxybenzoic acid, you don't have to draw the structure. Everyone just writes out the words MCPBA. This is the most common peroxy acid. So you should know this one. There's other ones too, but this is the one that you should know. So the reagent that you will see for this is either going to be MCPBA, or it will just say R or some sort of carbon group here, and then CO3H. Either one of these is a possible reagent that you could write down. So like I said, if you wanted the epoxide, you could stop at the first step, and this would be the product. But if you add acid or base to it, water with acid or base, then what happens is it opens up the epoxide, the water's a nucleophile, and the water comes in trans, and it will give you two OHs, and notice that they are trans to each other. The next way to make a diol or a dialcohol is to make it cis. It's called cis dihydroxylation, and that uses they're oxidizing agents that have a metal inside them. So the most traditional, or the most common, is called osmium tetroxide. So osmium is the metal that's in here. It's a transition metal, and it has 4 oxygens attached. So that's what makes it tetraoxide or tetroxide. And what it does is it lines up with the alkene, and it makes this, the mechanism involves making more than one bond at the same time. It kind of makes this cyclic mechanism structure, which gives you 2 oxygens, and they're both attached on the top face. So that means that they are cis to each other. And this intermediate is not usually isolated. It's an intermediate, and then you would do the next step without isolating the first compound. Then the next step is you would add a reducing agent, and this is a typical reducing agent, this sulfur reducing agent, and it would break the osmium bonds and give you the diol here. This can also be done with So osmium tetroxide, that's what we showed here. Another possibility is to use KMNO4, the manganese, as acts like the osmium with the 4 oxygens. The mechanism is the same. I'm not going to write it out. So these 2 are common. There's other ones that do it too, but these are the most common. These are the ones that you should know. And it will give you the what's called the cis diol. So both of the OH groups are pointing in the same direction. So now these are not in your packet, so use separate notes or a separate piece of paper to go through these and read the reaction, predict what the products are going to be, draw them out, do it on your own, stop the video, and take a few minutes to do this by yourself, and then turn the video back on and check your work. Okay, so one thing I want you to just pay attention to, not every reaction, all these reactions will make a diol, but only in some of them is the stereochemistry important. So in the first one, we see that the MCPBA gave us the trans diol, and in the last one, the KMNO4, which is similar to the osmium tetroxide, will give us the cis diol. In the other cases, there aren't stereocenters, so you don't have to indicate the stereochemistry unless you formed new stereocenters. And they're usually in a ring if you're supposed to indicate cis or trans.